How primary testing occurs. This is the question that has shaken humanity for the centuries. The problem of primality testing and factorization are two distinct problems. If we concentrate on primality testing, we never need to know the actual factors. The only question to be answered is the number in question prime or composite? Wilson's theorem. The integer p is prime if and only if p minus 1 is congruent to minus 1 mod p, since there is no known method for rapidly computing n minus 1 mod n in, say, log n steps. So Wilson's characterization of primes is of no practical value to the testing of the primality of n. There are many different primality tests, and they can be classified in at least three different ways. 1. Tests for numbers of special forms versus tests for generic numbers. 2. Tests with full justification versus tests with justification based on conjectures. 3. Deterministic tests versus probabilistic or Monte Carlo tests. Miller's test in 1976, G.L. Miller proposed a primality test, which was justified using a generalized form of Riemann's hypothesis. The APR test, the primality test devised by L.M. Adelman, C. Pomerantz, R.S. Rumley, 1983, also known as the APR test, represents a breakthrough because 1. It is applicable to arbitrary natural numbers n, without requiring the knowledge of factors of n-1 or n+1. 2. The running time t, n, is almost polynomial. 3. The test is justified rigorously, and for the first time ever in this domain, it is necessary to appeal to deep results in the theory of algebraic numbers. It involves calculations with roots of unity and the general reciprocity law for the power residue symbol. The running time of the APR is at the present the world record for a deterministic primality test. Soon afterwards, H. Cohen and A. K. Lenstra, 1984, modified the APR test, making it more flexible, using Gauss sums in the proof, instead of the reciprocity law, and having the new test programmed for practical applications. It was the first primality test in existence that can routinely handle numbers of up 100 decimal digits, and it does so in about 45 seconds. Monte Carlo methods. Ribbenboim mentions three Monte Carlo tests, due to R. Bailey and Wagstaff Jr., 1980, R. Solovey and V. Strassen, 1977, and M. O. Rabin, 1976, 1980. Elliptic curves primality proving, ECPP. ECPP stands for Elliptic Curves and Primality Proving. The algorithm is described in AOL Atkin and F. Moraine, Elliptic Curves and Primality Proving, to appear. It is a deterministic algorithm that gives a certificate of primality for numbers that can be as large as 10*1000, 1000. Follow my page and save this video so you don't miss the other videos that are related to prime numbers.